Here we go, we have a question sorted and rotated minimum. So you have given an sorted array of distinct elements and it is rotated. Then our task is to find the minimum element in it. So in this case, it is sorted, but it is rotated also. So the minimum element is 1. In this case, the minimum element is 1. In this case, the minimum is 2. So question is pretty straightforward. Let's try to build the approach. So I have taken this test case and the brute force will be to check each and every number. The time complexity will be order of n, but we can optimize it using binary search. How we gonna use binary search? So let's look. So first we have L here and then we have R here. Initially, I have answer as the 0th value. So I have answer as 9. Then I will try to find the middle point. The middle point is 3. So this is the middle point. So is it smaller than already contains value? Yes, this is smaller. So just update the answer. Then after that we need to check, is the right side sorted? Is the right side sorted? Yes, the right side is sorted. So the answer can be present on the left hand side. We have already considered the middle point. We have already considered the middle point, and all the elements on the right hand side is greater than the middle point. So there may be a chance that middle is the minimum value or the minimum value is present on the left hand side. So we will go on the left hand side. So I will just update my R to middle minus 1. So I have R at this point. Then the middle is this. Then is this value smaller than already contains value? No, this is not. Then we need to check, is the right hand side sorted? Is the right hand side sorted? No, right hand side is not sorted. That means the value is present on the right hand side. So just update your L to mid plus 1. So I have this value. Then I am inside the while loop. This is my middle point. Then I will just update my answer because middle is smaller than already contains answer. Then I need to check, is the right hand side sorted? Yes, from mid to R, from mid to from mid from mid to this value, from mid to this value. Is it sorted? Yes, it is sorted. So the answer can be present on the left hand side. Answer can be present on the left hand side. So just update your R to this value. Now we are outside the while loop and answer contains the minimum value. So that's how we can easily find our minimum value using binary search. So now let's look at the code. So we have answer. This is my initial value, then n, then L and R. So we have this while loop. Then we just need to find the middle point. Just update your answer. Then is our right hand side sorted? Is our right hand side sorted? If this is the case, the answer is present on the left hand side. So just update your R. If left hand side is we are not considering left hand side, we are checking with the right hand side. If right hand side is sorted already, we will go to left hand side. If right hand side is not sorted, we will go on the right hand side. Then just return the answer. But we can still optimize this. We can avoid our answer variable. We can avoid our answer variable. How? So we have this, then just remove this. We can just return, actually we can just return the value on the L, but it will get stuck if we have only one value. If we have a single value, so it will go inside this while loop. Then it will check, is the right hand side sorted? Yes, if this is the case. So if this is the case, either mid either mid be our answer or the answer is present on the left hand side, then it will get stuck. So we have to write the condition like this. Then we don't need our answer and we don't need our answer. So how this code will work? If we have a single value, we will not go inside this, we will just directly return the initial value. If we have more than one values, then we go inside this. Then we need to check, is the right hand side sorted? If the right hand side is sorted, then either the value is the middle value or the value is present on the left hand side. So just update your R. Now let's submit this, and I hope it will work. And let's talk about time and space complexity. As we are using binary search, so the time complexity is log n, and space complexity, as we are not utilizing any space, so it is constant. Code is given in the description box. And if you guys have any doubt, feel free to ask in the comment section. Give this video a thumbs up, and we have solved this question. And let's find out. And we have also met the expected time and space complexity. I hope you all learned something new. Thank you all for watching.